going ahead. Ready? Okay, very good morning to everyone here and all those who are watching it either on Zoom or on YouTube. Thank you for coming. First Sunday, usual, you've woken up for the science, which is really nice. Just in case somebody is new, Chai and Why happens on the first Sunday of every month, 11 o'clock here at Prithvi Theatre, on the third Sunday of every month at Mughal College in Matunga. And if a month has a fifth Sunday, we are usually doing something online from a lab in TIFR. Just to tell you that 15 days from now, 2 weeks from now, the next mid-month December Chai and Why this is when the Nobel Prizes will be given mid-December. So it will be on the chemistry Nobel Prize, which is something called click chemistry. That's what's going to happen mid-December. The next Chai and Why here is on Sunday, January 1st. Okay. So if you are in a position to come on Sunday, January 1st, if you've not had too much of a 31st midnight party, then you will hear about the Nobel Prize in Life Sciences medicine this year, which went to discovery of Neanderthal DNA and how it connects to us, etc. So that's going to be the topic for the next Chai and Why over here. And after that, we'll have one on the Physics Nobel Prize later on. So the next two Chai and Whys are on the Chemistry and the Biology Nobel Prize. Today, of course, we're going to look at something very different. We're going to look at how science evolved in India. And we have a master storyteller with us, Sreerup Raychoudhuri. Sreerup is a professor of theoretical physics who actually did all his training in Kolkata and then spent quite a few years at IIT Kanpur, an excellent teacher there. And then we sort of snagged him from there and got him here. And while he works on high energy particle physics or something, today he's going to tell us not exactly what he does, but one of his passions, which is to look at the history of science in India. Online audience, remember, the only way we can get your questions and comments is via chat. So please put your comments and questions in the chat box. We'll try and take it appropriately, either during the talk or at the end. I'll be monitoring the chat, so do that. So with that, Sreerup, I think we should start sharing the screen and
sure.
Going ahead. Because once we share the screen, this becomes a very tiny thing.
Do it for me.
Do that. Slideshow. Share. You are still sharing. Okay. One second.
Just move the
rotating control. Minimize this guy also. Get it out of the way.
Yeah.
Wait, it's on the light shade. Move it off the light shade. At the most, a couple of hours. But it's still on. Okay. This is working on YouTube. Yes. You're on.
Okay. Very good morning to all of you. And today I will be giving a Chai and Why with a difference, as Honorable has already announced to you. So this is the 75th year of our independence, and we are celebrating across the country. Hey, not moving.
Just click once because the last click was on.
Yeah. So, oops. We are okay. So we are celebrating the Azadi Ka Amrit Mahotsav across the country, and this is a good opportunity for me to talk to you about the evolution of modern science in India. So this talk will be not, well, of course, science is the background, but it will be more about the history of time, the personalities, and some of a little bit of science wherever it's required. So let's begin at the beginning with science in ancient India. And of course, there we do have a glorious history spanning some 3,000 years. I will mention only 4 of the important highlights. The first one is, of course, something which all of you know about, is the invention of the zero. And here is a clip from a manuscript found in what is now the northwest province of Pakistan. It's called the Bakhshali manuscript. And you see that little dot there, marked with a red arrow. That is 0. So this is the earliest example we have of the 0 being used anywhere. Then, of course, we have what we all study in school, the atomic theory due to the sage Kanada, the Vaisheshik Darshan. All right, surgery was very advanced in the Sushrut Samhita. So all these frightening looking instruments were devised very long back. And last, something which everyone does not know is that steel was discovered in India. In Tamil Nadu, it was called wood steel, and it is from India that people learned to make steel. And from here, it went out to the famous swords of Damascus or the samurai swords of Japan, and then swords of Toledo and so on. But the original discovery of that, if you mix carbon with iron in sufficient quantities, you do get this very strong material. So steel, as you know, was the first super material of the world. So that was the story. And of course, in addition to that, what we have left are the glorious examples of architecture and art. This is the Kailash temple at Ellora. Most of you may have seen it. And you see this large temple with all these detailed carvings. But if you do look at it from a different perspective, which is from above, you realize that it is just one piece of stone. So this is the largest piece of sculpture in the world. So certainly to design something like this, it's not easy. A lot of scientific knowledge goes in here. We don't know how they design, what plans they do, and so on. We only see the results after so many years. But there must have been there. Without that, you could not build such things. However, at the same time, contemporary with this, you look at the remains of Killa Rai Pithora. This is part of the Purana Killa complex in Delhi, which was built by the Tomar king Anandpal around 731. We already see that this is a very crude structure. Compared to the wondrous Kailash temple, already this has become crude. And you see the upper layer is even cruder. So what had happened? So by the 7th century, already there was a decline in scientific standards. So Acharya P.C. Roy, about whom I will be talking a little later, he wrote a book called The History of Ancient Hindu Chemistry, in which he talked about the reasons, what he felt are the reasons for the decline of what was quote unquote Hindu science. Okay, the word Hindu was not in use at that time. It was just Bharat or Jambudipa or something like that. But let us see. So the first reason he points out is the rise of otherworldliness. So the Advaita preached by Adi Shankara and others told you that the world is Maya, illusion. And your object is to get rid of this. It's to imagine yourself, it's to think of it as a useless thing. So if your world is Maya and useless, why bother about the details of how it works? So all the thinking people started lost interest, let us say, in the workings of the material world and concentrated on spirituality. This, according to him, was the first reason. The second reason is well known, is the cementing of the caste system around this period, where what happened is that people who worked with their hands and knew the results did not interact or talk to people who worked with their minds. So there's a separation between the two classes of people. And therefore, what happened was that the knowledge got fixed at that level. There was no further development because there was no crosstalk. The third reason, which he points out, is that the Hindu princes of that time, quote unquote Hindu princes, there's a constant bickering and warfare across India. So these are the years after the fall of Harshavardhan's empire. So much bickering and warfare all the time that these princes had no money and no interest in developing science or in propagating the scholars. All their money went to hiring soldiers. So without patronage, science died a natural death. Moreover, what happened was that life became very insecure in those days. So what happens when your life is insecure? What happens if you're uncertain whether you lose your job or you lose your life or your village will be attacked? Well, you go to an astrologer. And this is indeed what happened, that because of the insecurity of life, these quasi sciences or pseudosciences like astrology, alchemy, black magic, these things became important to people. Okay, it always happens. When you're insecure, you go to such people. So because of this, by the 12th century, science across India was generally in decline. And then came the invasion of the Turks from Central Asia. And these Turks, they had no interest in science. Well, that's not a fair statement. They were only interested at that point in plunder. So if you're going to plunder a place, you don't bother to support it for science. And here is an example of their handiwork. This is the ruins of Nalanda, destroyed in 1198 by Bakhtiyar Khilji. However, it's interesting that at the same time, there were scholars like Al-Biruni who were picking up the knowledge which they gathered from the Brahmin Pandits. And from their writings, they transferred it to the Middle East, where Islamic science suddenly had a great growth starting from this point. And eventually that moved to the West, created the Renaissance, and came back to India again through the Europeans. So it's a complicated story. But what matters to us is that in India itself, during this long period from about 1200 AD to 1750 AD, there was not much what we call science or advances in science had basically stopped. So these are what we call the medieval ages or the dark ages. Now, it's not that all knowledge had gone. We have these magnificent buildings from that period. Okay, that's the Konarka temple. This is, of course, I don't have to tell you what it is. This is Gol Gumbaz from Vijayapur. People were able to make these. So all knowledge had not gone, but the techniques what people were using were still old techniques. So the old knowledge which was being reused. The only place where innovative things were happening was in Kerala, where there was a school of mathematics or mathematicians who made many advances in what we in the road to calculus, in the theory of limit series, infinite series, and so on. But they stopped just before reaching calculus. The concept of the derivative and the integral, which are central to calculus, they stopped just before reaching there. They understood limits. So the only thing we have from this time, right at the end, 1734, is this instrument. This is an instrument, okay, it's an observatory called the Jantar Mantar. There's another one in Delhi, which many of you may have seen. So this was built by Maharaja Jai Singh. But why did he build it? It's not that he was interested in astronomy. He was not an astronomer. The point is that Jai Singh was a courtier at the court of Emperor Aurangzeb. Now, very famously, Aurangzeb didn't trust anybody, and all his courtiers were insecure all the time. So Jai Singh wanted to know what will be my future, and therefore he went to his astrologers, and they told him, "You build these observatories so that we can measure the motion of the planets very well, and then we'll tell you what will happen to you tomorrow, if you're going to lose your head or not." So, though it did a lot in the way of good science, it was not built for a scientific purpose. So therefore, modern science came to India with the Europeans. And of course, you know that Vasco da Gama came. That's not his ship, that's a British ship. So, and it is the British who brought modern science with them to India. But as I told you, the roots of that go back to the Renaissance, to Islamic science, and again back to India. So it came back to India in a roundabout way. All right. So I have written about this in my book, which I published last year, called The Roots and Development of Particle Physics in India. You're welcome to read the details if you want to. So that was a commercial break. All right, let's come to the British East India Company. Most of you know this part, that they first established a foothold in Bengal. And in Bengal, what happened was that there was a young Nawab, Siraj-ud-Daulah, and there was a conspiracy to remove him from the throne. And so it's common, it has to happen all over India. And the important people in it, there was his general, Mir Baksh, Jafar Ali, and then two of his main financiers, who is known as the Jagat Seth. I don't know what has happened to the TH, but and one of his main feudatories, Maharaja Krishna Chandra. The difference between this and 100 other intrigues which have happened in India over the centuries is that they called in the British under Robert Clive. And Robert Clive happened to be a particularly talented Englishman from his side and persistent maybe from our side, who decided that not only did what he want to help, so he won the battle, as you know, of Plassey with against the Nawab, and then he decided that he wanted to stay. Unlike others before him who had come, taken their payment or whatever, loot or something, and gone away. So that's where science started to come in. So what happened was that this is a map of Bengal from those days. So you see this region, shaded region here. So these are known as, there were 24 parganas. So pargana was a small, like a subdivision under the Mughal rule. So 24 of these parganas were ceded to the British. Why? Because the British were making such demands on the Nawab for money that he didn't have that in his treasury. So instead he said, okay, you take this place and you take the revenues from there and don't disturb me further. So that's what happened. Mir Jafar ceded this to the British, and then they became the owners or landlords of the 24 parganas. Now Clive went back and he was replaced by a governor called Robert Vansittart. Now Vansittart realized that the records of land holding and how much revenue to take was all chaotic under the Mughals. Whereas in Britain, they had a well-defined thing called the Domesday Book, where everything was written down. They had maps which showed every house, every tree, every little stream, every pond, and everything was written down, and the exact amount of revenue was noted there. He wanted to bring the same level of order and system in the 24 parganas. So he employed a young seaman called James Reynold to draw these maps, which Reynold did. And I'll show you an example. Here is a detailed map by Reynold of the Bengal presidency. So here, as you see, so this is, I mean, once he started, he wrote many maps. This map you can see at the bottom, it's from 1779, and it has been with the Asiatic Society since 1910. So he started drawing. So this is the first time people started drawing scientific maps in India. Earlier, people had drawn maps based on some estimates, but the first person who drew them to scale with the use of measurement and so on. So this is the first scientific activity, modern scientific activity, which started in India. Then, as you famously know, Robert Clive came back, fought further battles, and was able to get the Diwani of the whole of Bengal from the Mughal emperor. And by that meant that by Bengal at that time, it meant all the way up to Mughal Sarai. From Mughal Sarai to Chittagong. So this vast tract of land became effectively British. Receiving Diwani means you collect the revenue, collect the taxes. So, of course, that meant more work for Reynold. And indeed, Reynold took it up and he started making, as you see, the detailed maps are in the north. He has done some work in the south also. So never before had it ever been mapped so minutely. This is the first scientific activity due to James Reynold. Now, at about the same time, while Reynold was still working, Warren Hastings, who was the first Governor General, he realized that he needed people to be intermediary between the British, who didn't understand the local language and more, and the actual people of the country. So at that time, remember, it was still the end of the Mughal period. So the official language of everything was still Farsi, Persian, or Arabic in some cases. So he set up what he called the Mohammedan College of Calcutta. And the idea was to teach Persian, not Persian, Arabic, law, and natural philosophy. Little bit of natural philosophy, which of course today we call science. And of course, this was widely known as the Calcutta Madrasa. And this is a picture of the Calcutta Madrasa as it used to look, very beautiful neoclassical building. So this is still there. The Calcutta Madrasa still exists. It's been renamed the Alia University. So you can see not such beautiful parks anymore, but the remains of that old building, and you can see Calcutta Madrasa College there. And they do have a new building, a new campus outside the city, modern building, but not great on aesthetics. Let me now take you to the south of India. And if you remember that we have all learned that In 1799, Tipu Sultan was defeated, and the British were able to destroy his capital of Srinagar and take over the Mysore state. Now, during this siege, okay, I'll just come to this in a moment. During the siege, I should tell you that the British were deeply hampered, the British soldiers, by not knowing the territory. Around Mysore, it's hills and depressions and also ups and downs. And it was easy for the local people who knew the land very well to hide behind those. And the British often got caught in traps. And there's a particular story of one division of the British who, because they didn't understand the direction, they were marching by night and trying to get to the safety of their main body of troops. But actually, they were marching the wrong way. In the morning, they would have come right in front of Tipu's main army. And of course, they got destroyed. So one of their officers, one Colonel Lambton, so he had been in the Americas, and he knew how to navigate by the stars. So he looked at the stars and he said, "Look, we are going the wrong way. We should turn around." Fortunately, the commander listened to him. They turned around, and in the morning they were safe. So this inspired Lambton and also his commanders that the British needed proper maps. So in order to do proper maps, you have to do measurements. So for this measurement, Lambton himself, you see a picture on the left, and he initiated what is called the Great Trigonometric Survey. And this was started in 1806. It continued for many years. It ended only in 1843 when it was finally declared completed by Sir George Everest. I'll come back to Everest, a very famous name. The following, you see, here is an example of the kind of triangle. This is the example of the measurements they made. I'll explain it in more detail. Now, what was the Indian involvement in this? Almost nil in the scientific part. Indians were employed, as you see, to carry things, to cook, to fetch water, to do the menial tasks. But the entire work was done by Europeans. It was still European science being done in India, not by Indians. So let me just explain what this triangulation is. A little bit of science to justify it being a child white talk. So imagine you're a person standing here, and in front of you, you want to find the distance from yourself to that point up there, which is blinking up there. Now, the point is you can't just take a chain and spread it. Why? Because there are different difficulties. There's a deep, dense jungle in front of you. There may be some body of water. So you can't just stretch it like that. So what do you do instead? Instead, you choose another point where you can go, and you measure the length of this A here. And from here, you take telescopes with that point, and you measure these angles beta and gamma. And now you use a very simple trigonometric formula known to everyone, almost, I hope. And see, once you know beta and gamma, you know that angle alpha, and you see that there is one red thing in each of which is measured, and one blue. So you can just from here calculate all the other unknowns, which means that at the end of the day, you know the entire triangle, all its sides. Now imagine that you want to look at that point. Again, you can't stretch a rope there because you'll be going through that water. But what you can do is repeat the same exercise. And maybe you can't go from there directly here either. So once again, you set up a triangle and use your trigonometry to measure that distance. So what Lambton and company did, they started from the Mount of Mylapore in Chennai, modern Chennai. So here, this was their starting point. And from here, they built up this entire network of triangles across South India. So once you have these triangles, you have a scheme. It's like a skeleton, and then you draw the rest of the map based on those distances. So this was called the Great Trigonometric Survey, and this is the south where he started it, but eventually it stretched further north. Now Lambton himself wasn't able to take it too far. He died somewhere in the middle of Maharashtra at a place called Hinganghat, and his tomb is still there. So he was succeeded by Sir John Everest. I'll come to Everest in a moment. But meanwhile, I'll just remind you that during this period, while all this was going on, the British were happily conquering one Indian state after the other. Well, first the Mughals, Marathas, Sikhs, Saudis, and Burmese. So by 1937, but essentially by the 1920s, this is how India began to look. All the red, the pink areas are British. All the yellow areas are Indian states, subsidiary or subordinate to the British. And since this is Prithvi Theatre, I have to show you a still from a film. And I have picked Satyajit Ray's Shatranj Ki Khilari, where you do see the effect of the Ghoda Paltan, British troops marching into Awadh after deposing the Nawab. So this happened all over India. So good for the British or bad? Well, both good and bad, because wars are expensive. So by the 1820s, the East India Company, which remember was ultimately a merchant company, was seriously in debt. I mean, they were making a loss of something like £1 million per year. And so at this stage, they needed somebody to bring them out of the financial mess. So there was a Rishi Sunak of those days, and his name was Lord William Bentinck. So he was well known, among other things, as a financial wizard. So Bentinck was posted to India. And of course, we remember him today more for his famous reforms for banning sati, banning the throwing of infant girls into the river, banning, suppressing the tongue, and so on. But what the reason why so I should tell you that he made various reforms in the Indian administrative system, so that by the time he went back to England, the company was making a profit of £1 million a year. So that's a wonderful achievement from the British point of view, obviously not from the Indian point of view. Okay, but his right-hand man was Lord Macaulay, who was the member for justice in the Governor General Council. And in 1835, so there was a lot of conflict at that time about whether the British should support education of Indians in Persian, Arabic, or Sanskrit, or in English. So there was a group of people who were called the classicists, who wanted it to go on in Indian languages, and the group of people who were called modernizers, modern as in those days, who wanted it to be English training. So Macaulay was very much on the side of the modernists. So he wrote what in 1835, he wrote what is his famous Minute on Education. And he said that, okay, we cannot educate the huge mass of Indians. What we can do is to form a class who may be interpreters and so on. So essentially, people who have an English education, which they will communicate to the rest of India. That is the model we have followed throughout. In a sense, we all belong to that, which is why this talk is in English, not in Persian, which I don't know. Okay, a little bit about Lord Macaulay, because he has come very much before nowadays. So during the nationalist struggle in particular, and it's being repeated nowadays, Babington Macaulay has been vilified as a cunning villain who planned to train Indians and make them westernized so that they would remain slaves of the British forever. But actually, this was not his purpose. I mean, it is true. He was insular, he was priggish, he was racist, and so on. But that just shows he was a man of his time. All the Britishers in India were like that. But he was also a high-minded idealist. I'm quoting from a speech of his in Parliament in 1833. He said, "Are we to keep the people of India ignorant in order that we may keep them submissive? Or do we think that we can give them knowledge without awakening ambition? Or do we mean to awaken ambition and provide it with no legitimate rent? Who will answer any of these questions in the affirmative?" He's very clear. He has to say no to these. Yet one of them must be answered in the affirmative by every person who maintains that we ought permanently to exclude the natives from high office. I have no fear. The path of duty is plain before us. He thinks we should educate, or the British should educate Indians in their ways. And after that, Indians demand freedom and more, then so be it. And he goes on to say, it may be that the public mind of India may expand under our system till it has outgrown that system, that having been instructed in European knowledge, they may in some future age demand European institutions. Whether such a day will ever come, I know not. Here, that was his big mistake. But never will I attempt to avert or retard it. The scepter may pass away from us. Victory may be inconstant to our arms, but there are triumphs which are followed by no reversal. Of course, the rhetoric is very good, but notice that he is quite happy with it in a future age. What he did not realize was that 50 years from when he wrote this minute, already the Indians would be starting to demand self-rule. Okay, so it is the time scale which misjudged and not the basic principle. We'll come back to Bentinck, but the other thing which Bentinck realized is that the East India Company, see, he was worried about money. The East India Company had exploited all the resources of India as far as they could by taking money from the local kings, from the local princes, and so on. He realized that if you try to take more money from people, then there will be rebellions, revolt, which actually did happen after some years. But the result of those would be more wars, more expense. It would be better, according to him, to exploit the resources of the country directly. And so, if you want to, you want to know where the resources lie. So the most important resources of a country lie in the mineral wealth, in the forest wealth, in the animal wealth, and of course you have to know where all these things lie. So he started by reviving the survey of India, which had been started by Lambton and Everest, by the survey of India, and then he set up committees which later converted themselves into the Geological Survey of India, the Botanical Survey of India, and the Zoological Survey. Okay, these exact names came later, but there were committees formed by Bentinck to look at these. So from this point, the British became interested in directly investigating the resources of India. And of course, who does that job? Scientists. So at this point, scientists were needed in large numbers to do this job. All right, so now we see how Indians started participating in this. Again, not for an idealistic reason, but for a practical reason. So Sir George Everest, who was asked to set up the survey of India, he wanted 30 computers. Now, computers doesn't mean instruments like this. It meant people. It meant people who would sit with pen and paper and actually do addition, subtraction, multiplication in large numbers all day. Very boring work, but it was paid highly. Paid highly? That's where the question comes. So what Lord Bentinck told him is, look, I can't give you money for 30 computers at this high salary. Why don't you take some Indians who are educated and employ them at half the salary? So you see that the roots of outsourcing are not new. Okay. So here this man had the same idea. Now, where to find Indians who knew the kind of mathematics which could be done? So Everest approached the only place you could get it. He approached John Tytler, you see his picture there. He was the professor of mathematics at the Hindu Mahapathshala. I'll come to the Hindu Mahapathshala in a moment, in Calcutta. So he went to this guy, and Tytler recommended 9 young men. So they were all employed by the Survey of India as computers. Okay, computers means computing clerks, let's say. So these people were the first Indians to actually practice modern science and take part in the Great Trigonometric Survey. So these 9 people, however, 8 of them didn't last beyond 1 year. They got fed up, they chose other jobs and moved out. One guy survived, and he is India's first scientist. But before that, I'll just quickly come to the Hindu Mahapathshala. This was founded in Calcutta in 1817. It was known to the British as the Hindu College, and it later became the Presidency College. It also happens to be where I studied. And this is a famous stairs of Presidency Square. There's a story about Subhash Chandra Bose having pushed a British professor who was making disparaging remarks about, racist remarks about Indians down the stairs. Not probably the best thing to do, but it's one of the famous incidents you read about in history books. These are the 2 people who made it possible, Ram Mohan Rai and David Hare, who gave the blueprint for forming this new college. So it was here that the person I'm going to talk about, and that is Radhanath Sikdar. So Radhanath Sikdar was educated at the Hindu College or Mahapathshala, and he was recommended by Sir John Tytler to Everest. Eventually he became Everest's blue-eyed boy because he was simply brilliant at doing all the mathematics. Now, one of the things taken up not by Everest but by his successor was to try to find out the heights of the Himalayan peaks. And here he has his own surveyors, all Englishmen, did the preliminary survey, but there was a problem with measuring the heights of the Himalayan peaks. What was the problem? That because you had to do it by the triangulation method, of course, but they were not accessible. The highest part of the Himalayas lie on the border between Nepal and Tibet. Now, a few years before that, the British had fought a war with the Nepalese and taken away some of their territory, with the Gorkhas of Nepal. So the Gorkhas had made. On the other side was Tibet, where the Dalai Lama had made it close to all foreigners. So there was no way so close to the mountain. We had to measure them from the nearest place they were visible, which is the north of Bihar. So north Bihar, in the Muzaffarpur region, you could see the peaks from there and make measurements. That's about 100 miles from there. Now, when you make, first of all, that itself was a dangerous activity because the area in those days was dense jungle. So there are records of the surveyors saying, okay, 3 of my men have been taken away by tigers. Okay, 7 of my men died of malaria and so on. So, in fact, even the surveyors themselves came down with malaria. But that's a different story. What is important is that when they had to make these measurements over the long distances, there were 3 effects which came in. The first is that the earth is curved. So you can't just take it like a plain trigonometry. You have to take care of the curvature of the earth. The second thing is that you go through a long distance in the atmosphere, and there is some refraction in the atmosphere. So you have to correct for atmospheric refraction. And finally, when you do these measurements over a long period of time, the temperature in India changes. In North India, as you know, the temperature changes vastly over a year. Okay, it goes near freezing in winter and it goes up to nearly 50 in the summer, 50 degrees centigrade. So you have to take care of the expansion of the change with which you are measuring your baseline. The expert on making these corrections was Ramchandlal. So all this data was sent to Ramchandlal at Kolkata with his team. And they all sat and did the calculation, finally came to this conclusion that this particular peak, the one at the 1,002 feet, and is the highest peak in the world. All right. Now, there arose the question of whom to name it after. So the Surveyor General at that time was a man called Andrew Scott Waugh. He was the sort of main force behind this effort. The actual peak had been surveyed by 2 people called Armstrong and Nicholson. Calculations had been done by Ramchandlal, and there was another person who checked all the calculations called John Hennessy. So whom to name it after? Okay. So Andrew Scott Waugh came up with the idea that let's name it after our Guruji, who has taught all of us how to do survey, and that was Sir George Everest. So that's how it came to be known as Mount Everest. Now, so Everest was, of course, alive at that time, as he was in England. He was the man who protested most strongly because he had set up the theory, all Himalayan peaks should be named by the local name, which is why they all have the local names, right? You have Nanda Devi and Kamet and Machpuchare and all these things. Kanchenjunga. Now, so the reply is second, but we don't know the local name because we can't go there. We can't go anywhere within 100 miles of that place. Then Everest had a second objection. He said, people are going to pronounce my name wrong. They will not say Everest, they will call it Everest. And we all do call it Mount Everest. But all these were overruled. The Royal Geographical Society said it should be Mount Everest, and that's what it still is. However, the importance of that in my story is that he proved to colonials and to the colonized people alike that Indians could practice modern science as well as the Europeans. Before that, the colonial people had an idea that clearly racist idea that the Indian mind works well for mysticism, for spiritualism. It doesn't work well for practical things. Now he showed that I can do that. The Indian can do the practical things and do them quite as well as Europeans. In fact, he was the all right, let's move to the other end of the country and come home to Bombay. So roughly at the same time, there was a person in Bombay called Ardasi Kursadji. And as you can see from the name, he was a Parsi. And he is the first, so he was a man not mathematically minded, but practically minded. So he is the first technologist in the modern sense. In fact, in many ways, it is he who brought the industry into India. First of all, he was a member of the famous Wadia family. So Bombay dyeing had not been invented at that time, not been started, but the shipbuilding industry was there, and his father was the chief engineer of the Bombay docks, which had been built by their ancestors only. So he was there, and he built the first steam engine in 1831, built by hand. The first steam engine, it was a 1 horsepower engine, which he used to draw water out of a well in his own house. However, within 2 years, he had gone up to 10 horsepower and made a steamship. And that was called the Indus. And then by 1851, he built an 80-ton steamer. 80 ton is tiny compared to modern ships, but then by those days, it was a big ship. So he brought this shipbuilding and steam powered ships to India. But that's not all. In 1834, he used gas lighting in his own. This is not Ardeshir Kashi's house that has disappeared, but this is a similar house of those days, lit by gas. So gas lighting was brought to India for the first time. Now, where would you get the gas? Gas supply. Okay. So he made it in his own garden. He made a shed, and where they used coal and fractionated it and produced coal gas from there. Then he traveled widely, traveled to the US, traveled to the UK, and brought back from there many innovations, like the chainsaw for cutting timber, the sewing machine, photography, electroplating, name it, brought to India by Ardeshir Kashi. So he was, of course, at that time, very highly regarded by the British as a prime example of Macaulay's ground. Here is an Indian, but who does the kind of engineering work which the English are good at. And he was also the first fellow of the Royal Society. First Indian to become a fellow of the Royal Society was Ardeshir Kashi. Second was Ramanujan. So, and he eventually settled in Richmond with his English wife, Marian. So there's a story connected with that, which I won't tell you. So today, if you go to Richmond, you have this blue plaque, heritage plaque, that Ardeshir Kashi Wadia lived there. And of course, you know that Richmond has also produced another brown Englishman who is their prime minister. He's from, his constituency is Richmond. Okay. There's a forgotten mathematician called Ramchandlal. His full name was Ramchandlal Mathur. You see his picture on the left side in the turban. And he was a teacher in the Delhi College, which today is called the Zakir Hussain Delhi College. And it's one of the oldest colleges in India, not that building, of course. So he wrote this book called a treatise on problems of maxima and minima solved by algebra. And how do you solve maxima and minima normally? You use calculus. You take the derivative and put it to 0 and then solve. That's the standard way. But in Ramchandra's book, he doesn't use calculus. He just uses algebraic techniques. And thereby he arrives at, and then it starts with a very simple problem, how to divide a straight line into 2 parts so that the product is maximum. And then he goes on and on to more complicated problems of geometry, of spherical geometry, and so on. It's a wonderful mental exercise. And so this book, most people didn't take it seriously because the people who were looking at science in India were mostly engineers. They were worried about practical things. They were not worried about the beauty of mathematics. They wanted to get something and build the next bridge or the next road. So they wrote back saying, well, why do we need all this? We already have calculus. But one copy of the book managed to reach Augustus de Morgan, whom, if those of you know set theory, have heard of De Morgan's rules or De Morgan's laws. So De Morgan was then the president of the Royal Mathematical Society. It is De Morgan who recognized the beauty and originality in Ramchandra's work. And he wrote back, and it is because of De Morgan's support, and this is De Morgan's house, which is today and this picture is taken by me. So this is the door this says the Royal Mathematical Society. And below that it says Augustus de Morgan. Great. However, so it is De Morgan who gave the prominence to Ramchandra. And some people have therefore called him De Morgan's Ramanujan. You know, like Ramanujan was discovered by Hardy. So similarly, he's called De Morgan's Ramanujan. All right. Okay. All right.
Just hang on.
Yeah.
Your audience, just hang on.
Anyway, so let me tell you a little more about Ramchandlal while we are going on, while this is going on. So Ramchandlal, among other things, he converted to Christianity. By the way, Radhanath Singh had also converted to Christianity. So as a result, when the War of 1857 started, the sepoys were in charge of Delhi. Some groups of sepoys went from door to door trying to find Ramchandlal in order to kill him. So what he managed to do, okay, so what Ramchandlal managed to do is he managed to escape somehow. And he hid in different people's houses, their cellars. You know, in those days, people used to have this room underground. We just called it Tehkhana. And to just so it would be cool in summer. So he hid in various rooms and finally made his way out to the British camp. I think that is sort of, and then after that, the British employed him as an interpreter and various things. But he certainly, so perhaps because he was regarded as a British collaborator, during the freedom struggle, you will find that Ramchandlal has been completely airbrushed out of the story. That's why you never hear about him. But that he was the first Indian since ancient times to have original mathematical ideas, no question about that. Okay, so War of 1857, you know this. India was taken over by the Crown. The East India Company was closed down. Universities were founded in Calcutta, Bombay, and Madras. That's the Punjab story. And Queen Victoria was declared Empress of India. And there you see the Kohinoor. So now what happened? Now I'll bring you to a slightly different part of the story, which happened a little before this. And so the new British learning, which had been brought by Macaulay and others after him, was taken up enthusiastically by the Hindus, but not by the Muslims. I mean, even in the Mohammedan college, they continued to teach Persian, Arabic, and Sharia, not go with the new research. Part of this was because the Muslims in general were resentful that the rule of India had been taken away from the British. And earlier, the Mughals were the dominant. Mughals and their allies were dominant. Now the British had taken it away from them. So among the things, they stayed away from the English learning. Now all this changed because of Syed Ahmed Khan. So there's an interesting story here. So Syed Ahmed Khan, he was worked for the East India Company, but he was a scholar in Persian and Arabic and something. So from the time of Akbar's Wazir, Chief Minister, Abul Fazl, had written a book called the Ain-i-Akbari, which means, Ain means the ways. So the ways of Akbar's time. It's a description of Akbar's court. Now over the years, these things had got corrupted. So Syed Ahmed Khan brought out a definitive edition of this Ain-i-Akbari, correcting the errors and so on. You know, settling typos and typos of those types were copying mistakes. Okay, so having done this, so what happens if you write a book? You go to a famous person, ask him to write a foreword. So the corresponding thing for Persian book was to go to a poet and ask him to write a foreword in verse, which is known as a takreer. So who better to go to than Mirza Ghalib? That's Mirza Ghalib. So Syed Ahmed Khan went to Ghalib and asked him to write this takreer. So Ghalib wrote a takreer for him. But what Syed Ahmed Khan found is that the takreer is no way what he would have wanted it to be. So I'm showing you a translation of that takreer, and I'll read it out to you. This is parts of the takreer. So he says about, this is Ghalib talking about this idea of his to establish this text and edit the Ain puts to shame his exalted capability and potential. So he's wasting his time. I, who am the enemy of pretense and have a sense of my own truthfulness, if I don't give him praise for this task, it's proper. So he's not giving me any praise for doing this. It's proper that I find occasion to praise. Then he says, look at the Sahibs of England. Look at the style and practice of these. Science and skill grew at the hands of these skilled ones. Their efforts overtook the efforts of the forebears, I mean Akbar and company. The fire that one brought out of stone, how well these skilled ones bring out from straw. That means a tinderbox or matches. What spell have they struck on water that a vapor drives the boat in water? That's your steamship. Go to London, for in that shining garden, the city is bright in the night without candles. Look at the businesses of the knowledgeable ones in every discipline, 100 innovations. So it's not what you would expect from Mirza Ghalib, right? He generally confined himself to wine, women, and songs. But here he was giving a clear message to Sir Sairat Khan, and look, you're an intelligent guy, an educated guy. These are the things you should be learning, and forget about what Akbar did. So this edition of the Ain was published without a taqreer. Instead, Syed Ahmed Khan, he abandoned the study of history. First, he founded the Mohammedan Anglo-Oriental College in 1875. This later became the Aligarh Muslim University. You see its beautiful building. From this point, there was no looking back. More and more colleges were founded where Muslim boys, in the beginning, much later girls, started getting a Western education. So they came on par, let's say, within some 30 years. So in fact, throughout the 19th and 20th centuries, colleges proliferated across India. So I'll just let you see. So Presidency College was the first one. St. Xavier's College, Kolkata, 1860. Scottish Church College, 1830. These are the Calcutta colleges. See, the oldest Calcutta colleges. If you go to Madras, the Madras Presidency College, 1840. Loyola College and the Madras Christian College. These are the oldest ones. And of course, if you come home to Bombay, then Elphinstone College, St. Xavier's College, and Winston College. And the reason why I put them in these columns, the first column shows what are quote unquote secular colleges. These colleges were not founded by missionaries, Christian missionaries, but mostly with money from the local rich people, mostly from the zamindars when it comes to Presidency College and Madras, and mostly by the rich states of Bombay when it comes to Elphinstone College. The middle colleges are all founded by the Catholic missionaries or by the Jesuits. Those who have studied there will know. And these ones are all founded by Protestant missionaries. So they were the first people who engaged in college. And there were other colleges across the country. The Lagat Singh College in Muzaffarpur, the Ferguson College, of course, the famous St. Stephen's College from Delhi. The Calcutta Medical College, these are the first technical colleges. Calcutta Medical College, 1835, set up by William Bentinck. The Bengal Engineering College came in 1880. And the Thomason College of Engineering came up in 1854 at Roorkee. And today, this is the IIT Roorkee. It later became the Roorkee College of Engineering, and now it's the IIT Roorkee. And then education for women started a little later. The Bethune College, 1879, is another example. It's also an example of a wrongly pronounced name, because the gentleman whose name it is in had that name, B-H-U-N-E, but it's pronounced Beaton. But of course, everyone calls it Bethune College, like Mount Everest. Then we come to the Sarah Tucker College, which is in Tirunelveli, and of course, SNDT Women's University. So a little story about the Sarah Tucker College, which I want to spend a couple of minutes on. So Sarah Tucker was a lady who never came to India. Her brother James Tucker was a missionary in South India, and he used to write letters back to her. So Sarah Tucker herself was paralyzed from the waist down, so she lived her life in a wheelchair. But she was so moved by the plight of women, uneducated women, the way women were suppressed, that she decided that she had to do something for the education of women. So she raised, from her rich friends who were there in London, she raised the money and sent it to her brother James Tucker. And that they founded a school, later it became a college, and that is the origin of the Sairat Tucker College. So it's named after a lady who never came to India, never saw any Indian, but nevertheless is a benefactor of the country. All right, more scientific things now. The first, India's oldest research institute, was founded by Dr. Mahendralal Sarkar in 1856. You see him there. There's a long story with that, but I can't go into all the stories. So it's there in my book. So India's oldest research institute, and this is the original building. So this is the building, and here there was a young official, a young Tamil official who worked in the Audit and Account Service, but was interested in science. So he asked permission to work in these labs during evening. His name was C.V. Raman. So here you see a picture of C.V. Raman. This is a young C.V. Raman. Actually, this is from his wedding photograph, so he's definitely young. So, and it is of course there that he discovered the famous Raman effect, which I will come back to again. Now, of course, this association still exists. That building is no longer a part of the association. It's been sold to some college. And this is their new building. And this is a flourishing research institute in today's India. Now I have to come to the Indian Institute of Science. And again, sorry to start with, why do I have disparate people like Jamshedji Tata and Swami Vivekananda in this picture? The point is that both of them were going to the US on the same ship. And that's a picture of the actual ship, which is to do this liner, which used to go from, so they went from here to Japan, and they met on this ship, which goes from Yokohama to San Francisco, cross Pacific. So long time on the ship together, and they became very good friends. And on this way, the Swami Vivekananda asked him that, you are taking, why are you going to the US on this long trip? Swami was going to deliver the famous lectures which later made him famous at Chicago and elsewhere. But so Tata told him that, I have bought some land in what is today Chhattisgarh. It was in the central provinces. And there seems to be iron ore on this land. But I have sent it to British labs, and they tell me the quality of the iron ore is very poor. So I'm not convinced by that. So I'm taking it to the US in order to see if it is actually as poor as they have told me. So Vivekananda told him that, look, none of these people are going to tell you the truth. They don't want you to exploit the mine. They want to exploit it themselves. So you will all get these answers that it's of poor quality. So then Tata asked him what to do. He said, you set up an institute which will do these things in India. There will be your people, there will be Indians, and who will give an honest answer. So it stuck in Tata's mind. So when he went to the USA, he didn't get good answers. They all told him that it's poor quality ore. From there, he went to Germany, and the Germans told him that this is some of the best ore in the world. So those are the famous Baila de la mines of Chhattisgarh, with which Tata Steel started. So at that time, it struck him that, okay, you have a scientific institute in India. Now, so he put up the okay. So he put up this proposal, and it was turned down by the Viceroy, who happened to be Lord Curzon. So Curzon thought that Indians are not up to setting up a research institute of their own. However, when Lord Curzon went back to England, unfortunately by that time Jamshedji Tata had passed away. But his sons took it up, and these are the two sons, Sreerup Tata and Sairat Tata. You'll find their names all over Bombay. So these two people, these two sons, they set up the Indian Institute of Science, and it came up in 1909. And of course, today it is one of, if not India's top institute. All right. Now, the later half of the 19th century produced two outstanding Indian scientists. So till now, people have been thought of the good scientists, but on the periphery. And these, of course, are Sir Prafulla Chandra Ray, whom I quoted at the beginning, and Sir Jagdish Chandra Bose. And so Indians have given them better names than those knighthoods. We call them Acharyas. So this part is about the two Acharyas. So now let me talk a little bit about these Acharyas. So we'll start with P.C. Roy. I won't go through all the details. So he's widely known as the father of Indian chemistry. He was born in what is now Bangladesh, educated in Calcutta. He was deeply influenced by the lectures of Sir Alexander Pedler, who used to lecture at the Presidency College on chemistry. Then he went to Edinburgh, did his PhD there under Professor Sir Alexander Crumb Brown. Most people have forgotten about Alexander Crumb Brown, but he's the guy who taught us to draw circles and lines describing chemicals. So next time you draw H2O like this with a circle and O and so on, remember that this was invented by Crumb Brown. Anyway, his thesis was in double sulfates of metals. That's not so important. He returned to India back to Calcutta. First of all, he became a temporary lecturer at Presidency College in 1889, but it took him 5 years before he could inaugurate a research laboratory. Okay, just collecting the money to start it was difficult. So in the meantime, what research did he do? He did some very, very typically Indian research. He studied adulteration in mustard oil and ghee. And these are the things which he said I used too much. I hope nothing, there was nothing worse. But these are the things he said are used to adulterate. And he developed methods by which you can detect it. Then once his lab started, he made this discovery of mercurous nitrate. Now, why is that interesting? Because the mercurous radical of chemistry is very unstable. Mercurous compounds very easily decompose into mercury and mercuric compounds. Similarly, nitrites also tend to dissociate into nitrogen dioxide and nitrates. So nitrites are also very unstable. But what he found is, so if you combine two unstable things, it should be much more unstable. But he found something interesting, that if you combine these two, it forms a stable compound called mercurous nitrite. Okay, and this, in fact, is the first example of one very well-known result in stability theory, that you can combine two unstable things to get a stable thing. So, of course, that is about mathematics now, but his was the first discovery of that phenomenon. And of course, because of this, he made a series of studies of nitrites, and William Ramsay, who was then the president of the Royal Society, called him the master of nitrites. So he did other things also. He wrote that history of Hindu chemistry from which I quoted in the beginning. He founded the Bengal Chemical and Pharmaceutical Works. So the first example of a scientist as entrepreneur, which is a big desirable today. And then the first postgraduate department of chemistry in India was founded at Calcutta University. He was its head. He joined in 1916, and he was a lifelong bachelor. So he gave up his house. He used to live in the university. There was a room in the corner of the lab, which was his living room. He used to sleep there, eat there, everything. And eventually he died there at the age of 83. So in some sense, he was like an ascetic scientist. And he used to look like this. All right. So as I said, he set an example. These are the Bengal chemical works, and that's in the year of his centenary. So anyway, this is an old thing. I don't know whether they made that profit or not, but certainly they are still on their feet. And here's a range of products which are very well known across Bengal, all the different products which at one time this had an all India sale also. More important, P.C. Roy was also a fantastic teacher. So he would, in his classes, he would mix quotes from Shakespeare, Rabindranath Tagore, and of course with chemistry and so on. And he was a very popular teacher. And here you see him with some of his very famous students, okay, with whom I will mention a few of them later. Of course, S.N. Bose is here in that corner, M.N. Saha in that corner, who later became physicist. And that is probably one of the only pictures we have of P.C. Roy, not in a kurta, but in a suit. So the students are in dhoti. Okay. So let's see some of his most famous students. There was Nilratan Dhar, who brought physical chemistry to India, father of Indian physical chemistry, worked in Allahabad. There was J.C. Ghosh. He was an electrochemist, brought electrochemistry to India, worked in Dhaka University for many years, and then he held many important positions. I will come back to J.C. Ghosh towards the end of the lecture. And then J. Mukherjee, who brought soil chemistry to India. He became the director of the Pusa Institute in Delhi. And finally, last but certainly not least, Biresh Guha, who brought biochemistry. And his famous work is in the biochemistry of vitamins, especially ascorbic acid, which is vitamin C. And so he is known as the father of Indian biochemistry. So these were all P.C. Roy's sons. It's a good time for a story. So P.C. Roy had once gone to London to attend a meeting of the Royal Society, of which he was a member. And they had a get-together then with families and so on. So one lady asked him, so Mr. Roy, how many children do you have? So P.C. Roy said 73. So the lady was totally shocked. And she went to the president who happened to be Sir William Ramsay, and said, why have you called this man, this barbarian who has 73 children? Sir Ramsay laughed and said, he's not married, these are his students. All right, we'll come to J.C. Bose. So J.C. Bose, the interesting thing is that he was even more famous than B.C. Roy, and they were contemporaries. So it's quite a feat. So of course, today he's acknowledged as the father of wireless communications, but other things. So he studied at St. Xavier's College, Kolkata, and he was deeply influenced by a Belgian father, Eugène Lafont, who used to give wonderful lectures. He also lectured the cultivation of science. And his lectures were like Alexander Pedler was the inspirer of Roy. He was inspired by Father Lafont. Then he went to the University of London to study medicine. But then he found that the smell of disinfectant, which you will find in any hospital, he was allergic to that. And the word allergy had not been coined, but it always made him sick. So whenever he went to the hospital, he started throwing up. And so he couldn't become a doctor. So since he couldn't become a doctor, he became a physicist instead. So he went to Christ College, Cambridge, and then he did his DSc with his tutor was Lord Rayleigh. And then later he got a DSc. So he came back to India and he was appointed a junior professor at the Presidency College. And see, he started work on electromagnetic waves. See how up to date he was. They had been discovered in 1888. Within 6 years, he's working on that topic. And here he made a breakthrough. See, he perfected the radio receiver. See, at that time, Hertz, he could generate electromagnetic waves, but the receivers were of very poor quality. And mostly they could receive one signal, they could receive the next one. And you had to tap it and push it and so on. But he developed something which automatically corrects itself and can receive the next signal also. So he called it the mercury iron coherer. In 1896, he won the DSc for it. Then he went and demonstrated at the Royal Society in 1899. But he said, okay, this is for the world. I'm not going to patent it. Now, in hindsight, we don't know whether it was nobility, great nobility or great stupidity, because he didn't patent it. The result is that when Marconi developed radio and won the Nobel Prize for it, he used exactly Bose's coherer. The only difference is Bose said one bent tube and Marconi had a straight tube. Otherwise, everything is the same. Else is the same. So, and Marconi used it without acknowledgement, but Bose couldn't complain. He had not patented it. Okay. However, so it took all these years. Only in 2012 was he acknowledged by the IEEE as the father of radio. But he did more work. That's what is interesting. He also pioneered the study of microwaves. So regular things which people use in microwave technology, the horn antenna, dielectric lenses, polarizers, all created by Bose. And in fact, in order to create a dielectric lens, he used some of the simplest things. For example, he could find nothing else and it was expensive to order something from the UK. So he took a railway timetable. You know, you had fat railway timetables in those days. Those of you who remember. And then he put, tin foil plates in between the sheets. And that whole thing, he then tied it up with some string and it became a receiver, a microwave lens or a microwave dielectric lens. He was also the first person to use a semiconductor, to use zinc sulfide or galena tubes as semiconductor and as detectors of radio. Brown had the same idea 4 years later, and it is Brown who won the Nobel Prize. So Sir Neville Mott, the Nobel laureate of 1977, he actually said that Bose was some 60 years ahead of his time. So the semiconductor revolution, so this was being done around the turn of the 18th to 19th century. And all the semiconductor revolution happened in the 60s. So that's what he said about it. But perhaps even more famous is Bose's work in botany. So he perfected this fantastic instrument with the technology of the time, which is called the crescograph, which is still maintained as it was in the Bose Institute, Kolkata. So by a complicated system of levers, you can attach it to a plant, and then that screen there is smoked glass. So there's smoke on the glass, and there is a little thing which traces out the motions of the plant magnified by those levers. It will be magnified as much as 10,000 times. So with this, he proved many things regarding plants. He first discovered that plants have a pulse and a circulation, that they respond to stimuli. If you tear a leaf from a plant, the plant shudders. Plant actually feels something. We don't know what it feels, but it feels something. He realized that plants can communicate with each other through chemical messengers. These are all well established today. Then he went and discovered the phenomenon of metal fatigue. Now, where he went a little bit overboard is that, it led him to think that there is some consciousness in all of plants and metals. That's not acceptable to science today. Certainly, it was not acceptable in his day. And so he earned a lot of ridicule by that, but he also learned a lot of applause. So here's something from the Los Angeles, what is it called? Chronicle Examiner of whatever. So 1890s, early 1900s. So as you can read, plants can feel, sleep, suffer, get excited. So it created an enormous sensation. Then, however, we must say that at that time his ideas were not acceptable. Only in the recent years, let us say last 20, 30 years, the subject of plant neurobiology has been invented. These same discoveries are being made today, and they are the ones which are being set up as this new science. But a lot of it is identical with the work of both. Okay, today you have new names for it. That's all. So these are some of the students. You see M.N. Saha, J.C. Ghosh, S.N. Bose, D.M. Bose all at the back. Again, inspirer of students. And then when he retired from Presidency College, he founded the Bose Institute. This is the entry to Bose Institute, which is never opened. I've never seen that door open. And this is the main building as you go in with offices and so on. So Sarah Chapman Hall, who was a devotee of Swami Vivekananda, he donated 40,000 rupees for it. So that would run into so many crores today. And unfortunately, by the time this was happened, Bose was already 60 years old. So unfortunately, if he had had more money and more resources at the time when he was, young and active, we don't know where he could have gone. We can break now if you want.
Let's take a break, start tea, and then come back. Request you online. Just take a, this is back in 7 minutes flat. Okay, online audience, just hang on. This is going a little longer than usual. So just hang on. We will be back in about 7 minutes. Yeah, very quick, very quick. Right. I think he's already answered that question. It was about does the survey of India come into this? Did Mahasi Kanar give first atomic theory to the world? Can we say that?
Take it at the end.
That's not modern science, right?
It's not modern science, but I take it at the end.
Okay. Let's get some chai and come back.
Hello.
Online audiences, hang on. We will be back in a bit. Can you pause?
Can I pause?
No. Can I pause the live?
Yes.
Another 30 minutes? Almost. Yeah. Just check. Will you no information. No, we were signing each other. When they notice it. Yeah, child get unnecessarily cool. No, also this is the right person. This is the right. Because you will be switching gears from here now. Quiet. No, but I talk about the people. Yeah. Let me get this. Maybe
Okay. Okay, welcome back. I'll speed up a bit. Okay, we start. Okay, same. This is locked. Okay. All right. Now, I'll quickly move to one more character from that side. So Ashutosh Mukherjee, widely known as the Tiger of Bengal. He started off as a mathematician, and he was the first Indian to publish in scientific journals. And then later, he became a lawyer, a high court judge, and so on. He was the vice chancellor of Calcutta University, and he is the set of the first postgraduate departments of science and Indian languages in Calcutta University. So that's where postgraduate education just started. And the University College of Science was set up in 1914 with generous private grants from two gentlemen, both lawyers, Palit and Ghosh, and they donated 14 lakhs and 21 lakhs rupees in those days. Just to put it in perspective, this is what it would be in today's money. So very, very few private donors are so generous today. All right, let me move back to South. Sir M. Visvesvaraya, who is recognized widely as India's most famous engineer. So he was born in the Mysore state and he worked in the irrigation department in Maharashtra. And he designed what is called the block system of irrigation, which is apparently still in use. But what he's most famous for is the Krishnaraj Sagar Dam on the Kaveri, which people had to.
Oh, the monsoon is too wild to be dammed.
Created. I'll show a picture of that. He also designed various things. Great civil engineer, protect Visakhapatnam port, flood protection system for Hyderabad. These are some use. The Hirakud Dam on the Mahanadi was designed by him as a consultant when he was 90 years old. And so as you see, he lived to more than 100. He also, in 1950, that's again when he was 90 years old, he was advising on how to build the Mokama Bridge. Then after retirement, he had a second innings. He was appointed chief engineer and secretary of the government of Mysore state. He became various things, Diwan of Mysore state, Bharat Ratna, so on. And this is a list of the things he founded. So from the Mysore Iron and Steel Works to the Mysore Soap Factory, and including the land for the ISC was donated by him at the cost of 1 rupee. Here's a picture of the Krishnaraj Sagar Dam when the river is in full flow. And of course, behind it are the Vrindavan Gardens, also designed by Visvesvaraya, and which are, of course, today more popular as a site for shooting films. So, okay. Now I come to perhaps the most mysterious person in this whole history, that is Srinivas Ramanujam. As you know, he was a transcendent genius. He had developed mathematical results which people are still trying to prove. And here is a page from one of his notebooks. As you see, he doesn't prove anything. He just says these things happen, adding up all these results. Here is the corollary one for it. He just throws results out like that. Such notebooks full of these results. Some of them are still being proved. Some of them people don't know where those came from. So Ramanujam is amazing how he got this intuition. As you know, there has been a film about him. So called The Man Who Knew Infinity. This, of course, is not the actors who played this role. So this is supposed to be Professor Hardy, who was his mentor at Cambridge. And you also know that Ramanujam had a very short life. He died at the age of 37. When he went to UK, he contracted tuberculosis. And when he came back, there was no cure for it in those days. So we lost this great. So, but some of these results of Ramanujam are so amazing that it almost looks like he's a man from the future who has come back. And mathematical knowledge is much more. So, in a sense, he's the biggest mystery of the scientific world. I'm not saying that he actually came back from the future. It is like P.C. Mahalanobis was the father of statistics in India and also the creator of the 5-year plan. So we have sort of have and don't have them at the moment. But he was initially trained as a theoretical physicist, and he used to teach Einstein's general theory of relativity. And though the general theory was published in 1915, by 1918, questions about that were already being asked in this time. He was so much up with the times. However, while in England, he read the journal Biometrica and was inspired by the importance of statistics, and he started applying it to various things. And in India, while trying to use statistics to understand the phenomena of caste, the caste system, he discovered a measure called the Mahalanobis distance, which is today known as the D2 distance and is a basic thing of statistics. Then he started the Indian Statistical Institute. I'll forget about the details. He remained as director till the end. And he was a crucial member of the Planning Commission and oversaw the industrialization of India in the second and third phase. He also was the first to bring a computer, not a human computer, but a computer like this, an instrument, to India. The first computer in India was not made in India, but was bought wholesale and came at the ISI in Kolkata. This is a picture of his house, which today is a museum. It's in the Indian Statistical Institute, Kolkata, with that building at the back, blue building is the institute. And here you see a picture of Mahalanobis and his wife, with the poet Reynold, who was a frequent visitor to their home. Let me move to Lucknow. So Ruchiram Sahni was a scientist, rationalist, and social reformer. So he did various things, including he was trained in physics, but he was a professor at Lahore, and then he joined the Brahma Samaj, and he was both a scientist and a crusader against superstition and emancipation. He wanted emancipation of women and so on. His son is perhaps more famous, Birbal Sahni, father of dendrology, which is the study of trees and fossils. So he trained in botany and specialized in identifying new species of plants. He also pioneered the study of paleobotany. What is that? That is fossil trees. And he made lots of contributions to geology through fossils. Founded the Institute of Paleobotany. And through that, he came to work in archaeology and numismatics as well. So many areas. And today, this is the plan for the new Birbal Sahni Institute of Paleontology. And this is the first part which has come up with that dinosaur skeleton. Then I come to one of the first Indian women scientists, E.K. Janki Amal. And Janki Amal was a pioneering botanist and also India's first woman PhD. So she was educated in the south of India, and then she moved to Michigan State. She trained as a botanist, briefly taught at the Women's Christian College, and did her PhD at London. But what is more important is that when she came to work at the Sugarcane Breeding Institute in Coimbatore, there she worked on sugarcane. And in those days, the sugarcane was not as sweet as it is today. The level of sugar in the sugarcane juice was not so much. By breeding different kinds, she produced a breed which has a much higher sugar content. And that became the sugarcane which is cultivated everywhere. So tomorrow, so the sugar which was in your tea 5 minutes back came from a sugarcane which was bred by Janki Amal. Very few people know this. And then, however, in this Sugarcane Breeding Institute, there was so much of caste, because she did not come from the upper caste, caste and gender discrimination, that she got fed up and she went back to London. So she stayed in London. This was just before the Second World War. So she got trapped in England. She couldn't come back from there. She worked on cultivated plants, worked on other things. And then she was invited in 1951 by the Prime Minister himself, who had gone to London, met her, and asked her to come back to India. So she came back as the director of the Central Botanical Laboratory at Allahabad, where again she did something which may be on your plate later in the day, for all I know, which is that she did long brinjal, which you will obtain in the market. This is the natural Indian brinjal. But the round ones, the round black ones, which are more juicy, these were bred by her. And first bred in that laboratory at Allahabad, and then started growing across the river at Banaras, in the place called region known as Ramnagar. So if you go to North India, they will say Ramnagar ka bangan. So that means the ones bred by hand. And of course, they are freely available in the market everywhere today. So after retirement, she worked briefly in DRC, and then she also spared movements to save the Silent Valley. I think people have forgotten about it today, but this is a picture of her in old life. But certainly a pioneering botanist whose name should be remembered. In fact, her creation is on your plate every day, but rarely remembered today. Okay, some people do remember. Plant breeders have created this new rose and named it E.K. Janki Amber. All right, move back to Calcutta. So these were the glorious years of Calcutta University, 1914 to 1922. Never has such a galaxy of talent come together in India. All famous names. I've already mentioned two of them. Mahalanobis. D.M. Bose was the nephew of J.C. Bose, great scientist in his own right. And then the others, C.V. Raman. And these pictures are of the young age. These are probably more familiar. By the time they were older and of course famous. But let me just do another commercial. So there's a book which describes these early days. It's written by my friends Gautam Anirban and Rajinder, and it's called the Dazzling Dawn. Of course, university today is nowhere near this, though two of my friends do work there. So one word about each of these papers. D.M. Bose, who was J.C. Bose's nephew, he worked in nuclear and cosmic ray physics, and he was the first to search for what are called mesotrons, which today we call mesons. S.K. Mitra was the student of Raman. He discovered the D layer of the ionosphere and was the first to study the radio physics and radio science in India. B.B. Roy, whose name is almost forgotten, he worked with people like Bohr and Hertzberg, and then he reworked on X-ray spectroscopy. And his main discovery was that X-rays also undergo Raman cycles, the experimental discovery of that. Okay, two famous names, Meghnad Saha and Satyendranath Bose. So once again, they require talks separately to themselves. But Meghnad Saha discovered the Saha ionization formula. That was his one great achievement. The other great achievement was to have built India's first cyclotron indigenously. He was also became MP, and he planned the Damodar Valley project, which was India's first attempt to control a river and make, which used to flood regularly and so on. S.N. Bose, perhaps even more famous because of boson. He discovered the Bose-Einstein statistics in 1923. Einstein worked further on it, and he became a national professor. And then, of course, one of his greatest things which today we still have not achieved is to try to teach science in the Mansar. Okay. Then, of course, India's one and only Nobel laureate in science who worked entirely in India, that is C.V. Raman. And so C.V. Raman, he started publishing even when he was a student. And I really wrote letters to him about his work. And he addressed him as Professor Raman, but he was still an undergraduate student. And then he joined the financial service. As you know, I've told you this part of the story. He used to work in the evenings, and that's where he discovered the Raman Effect. Sir Ashutosh Mukherjee appointed him as Professor of Policy Professor, Chair Professor, without even a PhD, on the basis of his work. And later he was awarded honorary DSc. He was elected Fellow of the Royal Society in 1924. Later, he resigned in 1968 on a matter of principle. What was that? The Royal Society insisted on writing his name as Sir Chandrasekhara Venkataraman. And he says, in my country, the Sir has been abolished. Please remove that Sir. Royal Society, we will not remove it. So he resigned from the Royal Society. So, and then, of course, he won the Nobel Prize, also knighting, and he was the director of ISC for some time. Started RRI, won the Bharat Ratna. He was brilliant and outspoken, given to many controversies. But there is one story I should tell you about Raman, which I heard from the horse's mouth. Some years back, there was a talk at TFL which was being given by the late Abdul Kalam, former president. So he said that one of the things, when he became president, one of the things he wanted to look at the files of all the Bharat Ratna recipients. And being a scientist himself, he wanted to look at Raman. Then he found this interesting correspondence. So Raman was sent a letter from the President's office saying, you have been awarded the Bharat Ratna. It will be awarded on so day. Please come to receive the award. And Raman writes back saying that, sorry, on that day, my student is giving his PhD viva and I cannot come because I have to be there to support him. Okay, I can't imagine a scientist today, sorry, with all respect, doing that. Of course, fortunately, the president at that time was also an eminent scholar. That was Dr. Radhakrishnan. So Dr. Radhakrishnan's note there is to the secretary saying, you find a date when he will come, and whenever he will come, we will organize a ceremony and give it to him. So he came on some later date and took it. I have to tell you this. All right. So as you see, this is Raman with all the other Nobel laureates right here. And still, it's the only one. We're still waiting for another one. Okay. So now I come to the independence, the Azadi, which I started off with. And since there are many, many scientists in the post-Azadi period, with whom I will not talk about individually, but I'm only going to talk about the main institutions which have come up. So the first one, of course, I have to mention is the Department of Atomic Energy, where I work. So it started by Homi Bhabha, a great son of this city, educated at Mumbai and Cambridge. He founded TIFA in 1945. That's TIFA, where I work. And then he started the Atomic Energy Commission in 1950, founded BRC, that's the first reactor. And as you know, he tragically died in a plane crash in 1966. But if it had not been for Bhabha, then India's first explosion, this is the Pokhran 1 explosion. There are people maybe a few people in the audience old enough to remember this picture in the newspaper, this very grainy picture, which came with the picture of Mrs. Gandhi, who was the Prime Minister at that time. And of course, the code name of this was the Buddha smile, which meant the explosion has gone off successfully. This would not have happened if it had not been for the pioneering work of Homi Bhabha. Vikram Sarabhai, similarly, educated in Ahmedabad and then at Cambridge, he returned to India in 1940, founded the PRL, started ISRO, and so on, as you know. He died in 1971 at the young age of 52. But by then, all these achievements had been made. So that's the Physical Research Laboratory up there, and that is the headquarters of the ISRO, which is down there. And of course, thanks to him, today we are able to launch our own satellite, and we have a rocket program, all because of Vikram Sarabhai. Shanti Swarup Bhatnagar set up the CSI. He was a chemist, and he was educated at Lahore and then at London, and he founded which is called the BSIR, or Board of Scientific and Industrial Research in those days. Then he started 5 labs in 1943, including the National Physical Laboratory and the National Chemical Laboratory, and he remained its Director General until he also died, not so young, but still died suddenly in 1955 while he was still the chair. So today, of course, he's famous because of the Shanti Swarup Bhatnagar Award, which are India's top awards. I hope they will stay in science and technology. You see here a picture of some years ago of the award winners with their award, and that's with the Prime Minister and the then Principal Scientific Advisor. D.S. Kothari he didn't found the UGC, but he made it whatever course it is today. So he was educated at Allahabad, where he did his MSc project with Meghnad Saha. And then he went to Cambridge and did his PhD with Rutherford. Then he returned to India and worked at Delhi University, where he is responsible partly for setting up the Delhi University Department of Physics. He was chairman of UGC for a very long time, and the Kothari Commission, which is on education in India, and a lot of whose things have been now again reincorporated in the National Education Policy of 2020, was chaired by him. He was scientific advisor to the Ministry of Defense. And most of the DRDO labs were founded under his, and so therefore, when the order went from the Prime Minister to build a new Indian aircraft carrier, we have behind it the skills development started with D.S. Kothari. All right, the only person in my list who is still alive, he's 97 years old, M.S. Swaminathan, who brought the Green Revolution. And you may, again, there was a time in the 1970s, which I remember from my childhood, when every day the newspaper would carry a small column saying malnutrition death somewhere, malnutrition death somewhere. We all knew that those malnutrition meant starvation death. So the fact that you don't see them, younger people have not even heard of them, is because of this gentleman. So he, of course, worked on botany and he did agriculture science. He joined the Agriculture Research Institute of India in 1947. First, he developed high-yielding potato varieties and then the high-yielding rice and wheat, which led to the Green Revolution. And the UN has hailed him as the father of economic ecology. So when you see these vast fields in the Punjab and Haryana, then this is entirely due, well, the scientific input came from M.S. Swaminathan. All right. Verghese Kurian. So he was educated and he had a choice between becoming a nuclear physicist or becoming a milk producer. So he chose milk production because he felt the country needed that more. So of course he joined the Anand Dairy at Kheda in Gujarat and then created Amul Corporation. And the rest I don't have to tell you. And there is a list of Amul products. Some of them are in your fridge. So Amul, of course, he also pioneered, by the way, the famous Amul cartoon. So this is a cartoon which came at the height of the farmers' agitation. And this is a so recent one. The early struggles of Verghese Kurian are portrayed in the film Manthan, which many of you may have seen, Smita Patil. Can't talk about modern India without describing the IITs. So the IITs were first conceived of by Sir Ardashi Dalal, whom you see at the top. He was formerly a manager of Cisco at Jamshedpur, but he became a member of the Viceroy's Education Council sometime before the independence came. So he had conceived of these mighty-like institutions across India. And then Sir Nalini Ranjan Sarkar, whom you see in the middle, okay, he chaired a committee which laid out the blueprint for a whole new set of science and technology institutes. And that is what has been followed after that. Dr. B.C. Roy, the West Bengal Chief Minister, whom you see up there in the corner, he provided the entire, see, this Hijli jail was a jail which was specifically built to house Indian freedom fighters. So after 1947, it became irrelevant. So they repurposed it to become the new IIT. Okay. And of course, IIT students say that the nature has not changed, but that's a different story. So then Sir J.C. Ghosh, who was the director of ISC, he moved to, and it is he who really set up the blueprint and the details of how an IIT should work, which is still being followed. And the IIT Act was passed, and it was all steered by J.C. Ghosh, became institutes of national importance. So the fact that today there is a craze for IIT education is because of the high quality of education imparted. And we owe it to these gentlemen, especially to J.C. Ghosh. Okay, this is how Kharagpur IIT looks today. Other IITs came up. IIT Bombay was the second, then IIT Kanpur and Madras together, and IIT Delhi a year later, a couple of years later. Today, IITs all across India. Now, I will bring you to somebody who is not a scientist, but who yet contributed to a scientific, and that was Rajkumari Amritkar. So Rajkumari Amritkar was a member of the Kapurthala royal family, and she had been educated at Oxford. She was a freedom fighter. For a long time, she served as Gandhiji's secretary, you see, for many years. And she also founded the All India Women's Conference. So in the first cabinet of India, she was appointed as the Central Health Minister. And it is she who conceived of the All India Medical Institute. The first in Delhi, it actually was set up in her own house, which she donated for this purpose. And in 1947, she was called the Time Bomber of the Year. What is that other picture that is at AIIMS? That is the first dose of co-vaccine being given. And of course, you have been familiar with aims. So these are all the aims. The red ones are the aims which are supposed to, no, there are aims which exist, and the black ones are supposed to come up. So just like you have a network of IITs across India, you will soon have a network of aims also. As you see, South India doesn't have them. And of course, you have seen this picture throughout the COVID pandemic. And this gentleman was the aims director at that time. And you all remain glued to the screen asking, wanting to know what to do next. All right, so time to finish. So one of our famous prime ministers, Lal Bahadur Shastri, coined this phrase. You may have heard of it, Jai Jawan, Jai Kisan. And you may remember that another prime minister added one more line to that. That was Jai Vigyan. So on this note, Jai Jawan, Jai Kisan, and also Jai Vigyan, I will conclude my talk. Thank you for your attention. And of course, Jai Hind. Yeah, she'll take questions from this. Okay, you come. Okay, this is disputed because we don't know the exact date of Master. And the dates for him range from the 8th century BC to the 5th century AD. So that's a vast period of time. We know that the Greeks, by the time the 4th century AD, BC, they already had an atomic theory. When Kanad, first, if he was 8th century BC, then he was the first. If later, then he was not. But this is still a controversy, and I'm not an expert on this part of the controversy. But I can tell you one thing, that the argument which Kanad gave for having atoms is wrong. And the argument which the Greeks gave for having atoms is also wrong. But both of them gave wrong reasons, different wrong reasons, but they got the right answer.
Okay. One last question is there online, which is apparently Ian Ramchandlal's work was delayed in review by critics, etc. colonial thing. Is there still a bias against the science in spite of all this?
I would say yes. I would say yes. And Indians have come a long way. But I think the bias is not so obvious in the way it was with, with Eddington and Chandrasekhar, or with Crick and Ramchandlal and so on. But it is there in a more subtle way, which professional scientists in India, I think, do feel it. The simplest way of seeing that is that, I mean, we have all faced it, that when we worked in foreign countries and wrote papers, the number of citations of those are far greater than the one we wrote when we came back to India, irrespective of the quality of the paper. It is there. There is no question.
So on that note, thanks Sreerup again, and I'm going to end the.
There are a couple of questions on the back. Huh? Okay.